Lesson 88, separable differential equations. I feel like that's a tongue twister. We are looking today at more how to work with and solve, like as you look at example 1, a differential equation. So something that's a derivative, how to solve that. We'll look at general solutions, we'll look at specific solutions, if I'm recalling the right lesson here. Yeah. Okay, so first of all, there's a few steps here. 1, get all of the y values and x values on opposite sides of the equation. And when I say, so we're separating, right? We're putting y's on one side, x's on the other side, including dy's and dx's. So we'll separate our dy, dx. After that, our job will be to integrate each side of the equation. As we integrate each side of the equation, when you integrate an indefinite equation, of course, you need a plus c. We don't need a plus c on both sides of the equation, so typical is to put it on the x side. And then we will solve for y. In other words, our goal will be to make the equation y equals, if possible, depending on the situation, and then leaving that c in the problem as part of the answer. Now, sometimes we'll be given specifics, and we'll be able to substitute in and find what c is to make the equation more specific. Sometimes we have to leave it general. So as we look at example 1, solve the following differential equation. So if we go back, step 1 is to separate y's and x's. Y's on one side, x's on the other side. What does that mean we need to do here? Yeah, move dx over. And in order to move dx, if it's dy divided by dx, we're going to multiply. So I'm going to keep the dy where it is. And then I'm going to multiply 4 cosine x by dx. So I have dy equals 4 cosine x. Y is on one side, x is on the other side. My job is to integrate. What is the integral of dy? So basically, what is the integral of 1? Just y. What is the integral of 4 cosine x? Okay, I was going to say, and keep in mind that 4 can just be pulled out front as a constant. The integral of cosine x is sine x. We just integrated both sides, so of course we need to say plus c. Okay. In this one, it is y equals already. I mean, if that was something where it was y squared or y cubed or 3y, we might have to do something to both sides to solve it. But in this case, it's y equals. And so we're done. It's your very basic, easy example there of how we can go backwards. Okay. Now, before we move on to example 2, notice it says, remember our exponential growth and decay formula. And then it says it is derived from doing this process. Exponential growth and decay, I don't remember what variables we used at the time. I'm going to use the variables I have written down here, because I have written down Q equals AE to the KT.
I think we did like A of T instead of Q.
I would say, that's what I was just thinking. I don't think we did Q at the time. I don't remember what we did instead of Q. A of T might be right. Or I really can't remember what. Was it?
Yeah, I always do that in the homework.
Okay. Okay, so now I'm saving some time here. I'm not going to take us through the process there of going from this differential to that, but just reminding you our exponential growth and decay formula you've seen in homework. Shall I guess, was there some in homework last night maybe? Kind of leading into this? It wouldn't surprise me if there was. I don't know for sure, but
Yeah, no, it definitely was the first one because it was like worded weirdly, and I couldn't figure out like that it was
What to do with it?
Yeah.
Okay. Okay, so let's look at example 2 down there. I'll go to my next screen, but we're going to use these setups. Now, it looks like instead of Q, I use N. I think I must have just used N to go with the book. But so look at example 2. Of course, we need to probably start by reading it. The rate at which a certain bacteria colony is growing is proportional to the number of bacteria present at that time. At time t equals 0, there were 1,000 bacteria. At time t equal 1, there were 1,050 bacteria. Write an equation that describes the number of bacteria present as a function of time and determine the size of the bacteria colony at t equals 4. Okay. I'm going to stick with what I used in my notes, and that is the fact that to refer to this bacteria colony, I used N instead of Q. And that must have come from the book because that's not, I don't know, it must have come from the book. As we look at given information, so we kind of gather what we have. At time t equals 0, there were 1,000 bacteria. At time t equal 1, there were 1,050 bacteria. And then we're being asked to write an equation that describes the number of bacteria present as a function of time and determine the size of the bacteria colony at t equals 4. So we're actually doing two pieces there because we're going to write the equation and then we're going to use that equation to find at t equals 4. Okay, let's see. I'm going to use, instead of the Q's, I'm using N from up above. So if you look up above, it was dq. I'm going to say dn over dt equals kn. And then, of course, keep in mind the equation I just gave up above of Q equals, well, again, since it's bacteria at time t, I'm saying N of t equals AE to the KT. Now, if I write down some information, at time 0, there were 1,000 bacteria. So at N of 0, there are 1,000 bacteria. At time 1, so that means I'm going to say at N of 1, there were 1,050 bacteria. We're being asked to find N of 4, right? They gave us N of 0, N of 1. We're being asked to find N of 4. Ah, that's the other thing we need to talk about. We need A. A is the original, so that means in this case, A is 1,000. I knew I had 4 things written down in my notes. I was like, what's the 4th? So if A is 1,000, that means this equation, N of t, can be rewritten as, instead of AE to the KT, we can say 1,000 e to the KT, because remember that A is the initial. I guess I called it N of 0 earlier. Oh well. How do I find K? Because in order to have a formula, I need to know K.
Well, at some point you take a natural.
Yeah, so we plug in, it's like, what is the,
If we're trying to find K, we have to plug in a time and the amount at that time. The time and amount that we know that we haven't used is time 1, there's 1050. So that's what I'm going to plug in. So instead of n of t, n of 1 is going to be 1050 equals 1000 e to the k times 1 officially, because it's kt.
Where was like in the natural log? Is that from?
We're not there yet.
I definitely remember doing that last night.
Yes, we are. You are right. Because when you said that, I was like, natural log. Oh yeah. That's give me another step before we get there.
In chemistry today, we were doing logarithms, and I did left, right, middle, but Doc does some weird 10 times x or 10 to x or something like that.
It works out the same. Okay. Before we can take the log. What? You might have said it.
Divide, though?
Yeah, we don't want to take the log, because the idea is we're going to need to take the log of that e to the power to get that k out of the power. But we don't want to take the log until that 1000 is gone. So we divide the 1000 over. So divide both sides by 1000. We divide both sides by 1000. 1050 divided by 1000 is 1.05, I think. Yeah. So then you have 1.05 equals e to the k. Now I'm at that stuck point of I need to know what k is, but k is stuck in the exponent. So now I'm going to take the natural log of both sides. So the natural log of 1.05 equals the natural log of e to the k. And if you recall, the natural log of e to the k, keep in mind this is, natural log is base e, isn't it? So I just taught this in Algebra 2 yesterday. When the bases are the same, it's the identity property, and this is equal to the exponent. So what is k? K is natural log of 1.05. So I can rewrite my new equation. So n of t is 1000 e to the natural log of 1.05 times t. That's my equation there. And now we plug in our nice little 4. He makes it sound so easy. Yes, it is, as long as you have your calculator there, right? So 1000 e to the natural log of 1.05 times 4. I will say, make sure you know how to plug it into your calculator. I mean, it's not horribly difficult, just, actually it shouldn't be bad on these calculators. Are you getting it? Yeah. I was going to write down my calculator answer of 1215.50625, but okay. I have it written as 1215. This must be something. The size of the bacterial colony, there's only 1,215 full bacteria. And so we don't round up to the nearest whole.
It was like halfway through. It's like it's got all the extra stuff. It's just still.
Yeah, so I have 1,215. Bacteria is my answer. And that's one of those where technically in calculus we're supposed to give a minimum of 3 decimal places. But on a situation like that, we're going more for whole numbers. So
like, what would AP expect?
that is a good question that I am not sure of. What would AP expect here? I feel like you'd want to go 3 decimal places unless they tell you otherwise. And this could come down to, I can't say that I've ever seen something like this actually in the open-ended. So maybe more in multiple choice. And so then if it's multiple choice, you're picking. And it's not like they're going to say, okay, is it 1215 or is it 1215.506? They're not going to give you those 2 answers.
They did not.
So
I would answer both of them.
it would be rude. It would be mean. I get it. So okay, example 3. The slope of a certain curve is twice the value of the x-coordinate everywhere. Find the equation of the curve given that it passes through the point 1, 2. Okay, keywords. Slope. What's slope make you think? The what? Derivative. So based on what we're doing today, I'm going to say dy dx because we're talking about these differential equations, right? So the slope of a certain curve is twice the value of the x-coordinate everywhere. So how do I write that? 2x. So dy dx equals 2x. So we're being asked to find the equation as it passes through 1, 2. Well, what are we going to do to find the equation here?
Is this like the very first example?
Yep, back to like the very first example where we are going to want to integrate. Before we integrate, we need to separate x and y. So I want all the y's on one side, x's on the other side. So I'm going to keep my dy here. I'm going to multiply dx the other side and make it 2x dx. Now that my y's and x's are separated, we're going to integrate. The integrate the integrate of dy. The integral of dy is y. The integral of 2x. How about we just go x squared? How about we just add 1 to the power? So we're going to add 1 to the power. It's going to become x squared. You divide by that new power, and the 2's cancel out. I feel like you integrated twice is what I feel like you did, but
Maybe.
I don't know, because you added 2 to the power and divided by it. I don't know. And then, of course, we need to say plus c.
Is this just like a different way of doing it?
Well, we're not done.
I mean, like the integral part, like splitting it out.
Somewhat. And there are specific situations where this is more helpful.
Okay.
I know as you look at some of these, you're like, I could have done this without.
Yeah.
Like, I didn't need to think that way. But there are times where it is more helpful. These are more the basics. Now, we're not done because we were given that it passes through the point 1, 2. Which means, since we were given that information, 1 and 2 are an xy value, so we are able to find c. So instead of y equals, I'm going to say 2 equals. Instead of x squared plus c, 1 squared plus c. So 2 equals 1 plus c. And so c is 1. If c is 1, then we can rewrite our new equation as y equals x squared plus 1. And that is our more specific solution. Okay? Up on the example 1, we had a general solution because we just had to leave it as plus c. I couldn't go any farther. Right here, I was given information that I could use to find c, so I had a more specific solution. Okay, moving along. Example 4. Find the what? General solution to the differential equation x dx plus y dy equals 0. So this means we're going to get to leave the plus c in the answer. Okay, step 1.
Oh.
Okay, we want to separate x and y. So if I leave my y dy on the left, and then if I take my x dx and I subtract it over, I'm going to say negative x dx. My x's and y's are separate. So now I'm going to integrate. What is the integral of y dy? One half y squared. What is the integral of negative x? Negative 1 half x squared. And then, of course, we need to tack on a plus c. Okay. Now, this is one of the situations. Notice it said, what did it say? Solve for y if possible. And I'm not going to say it's not possible here, but there's also other things that can happen too. First of all, I don't know about you guys, but are we still not crazy about fractions even at calculus level? You know. How do we get rid of those denominators? Multiply by 2. Now, something a little different about these equations. Yes, we already tagged on the plus c, but that plus c just kind of carries down as a c. We're not going to really do anything with the c other than just keep it carrying on. So I just put it in the parentheses that we're multiplying everything by 2, but I'm not going to really multiply that c by 2. And so 1 half y squared times 2. 1 half and 2 are going to cancel. We have y squared. 2 times negative 1 half x squared. The 2 and 1 half are going to cancel. I'm going to have negative x squared. General rule of thumb, you just leave the c. Leave the plus c. Now, we could solve it for y. Or I could put it in a different form that is a familiar form if you think about it. And that is the fact, what happens if instead of solving for y and square rooting, what happens if I add the x squared over? It's what? Yeah, it's also the equation of, what is y squared plus x squared equals, this says c. Equation of
a squared plus b squared.
No, don't think Pythagorean there. What if I say y squared, or x squared plus y squared. I just wrote that in the backwards order of what I wanted to write. Gosh darn it. Because generally, whoops.
Oh, is it circle?
What just happened? Okay, I can't get my C back. Generally, it's x squared plus y squared equals c, and yes, I was trying to lead you to a circle.
Okay.
I was getting ready to say x squared plus y squared equals r squared, and then I was annoyed by myself that I had y squared plus x squared, but not that it really matters. It just seemed more natural to me to say x squared plus y squared. Okay. Example 5. Last one. Given the differential equation, y prime equals 4x squared y squared, find the particular solution y that passes through the point 1, negative 1. First of all, y prime is the same as saying what? dy dx. So this is dy dx equals 4x squared y squared. We're eventually looking for the particular solution, but right now we have to find the general solution. Okay, multiply dx to the right, divide by y squared. I would just leave that 4 with the x squared because I'd rather not make fractions unnecessarily. So I'm going to say keep the dy. I'm going to divide y squared. So for the moment I'll write it as dy over y squared. I'm going to keep the 4x squared, and I'm going to multiply by dx. Now, I wrote it as dy over y squared, but dy over y squared is y to the negative second dy equals 4x squared dx. That would be the best form, I think, to write it in. Now we are ready to integrate. What is the integral of y to the negative second? Add 1 to the power, divide by a new power. I have negative y to the negative 1. That's what my brain says. I'm going to write it in a different form here in a moment. Add 1 to the power of 2 and it becomes 3. Divide by 3 and we have 4/3 x cubed. And then I also need to say plus c. This negative y to the negative first. Based on the fact we need to solve for y, this is better. What about that negative exponent? It's negative 1 over y. And you could have written that in the last step, definitely. But this is not one where I can just leave it at all. So, how do I get y out of the denominator? Okay, if it's divided by y, we can multiply it by y. You know what? If we're getting rid of fractions, what other denominator can I get rid of? 3. So I'm going to say multiply both sides by 3y because those are my denominators I want to get rid of. Does that make sense why I'm picking that? Now, as I write this out, I'm running out of room. 3y times negative 1 over y. That just becomes negative 3. The y's cancel. We have negative 3. On the right, remember that plus c is just going to kind of hang as a plus c. When you do 3 times the 4/3, the 3 will cancel, yes? And so I don't really want to multiply that y fully in. So I'm going to write this, the 3's cancel, as y times the 4x cubed plus c. My reason for doing that is I still have to take another step to solve for y, don't I? And so now, since I did y times the rest of that quantity, I can divide by that quantity. And so I'm going to have y equals -3 over 4x cubed plus c. Now, keep in mind, this is my general solution. This is my general solution because it has plus c in it. We're not done because they want us to find the particular solution, of course, right? They want the particular solution using 1, -1. So, fill in. Y is going to be -1 equals -3 over 4 times 1 cubed plus c. Clean it up. -1 equals -3 over 4 plus c. We have 4 plus c in the denominator here. So what if I say I multiply the 4 plus c to the other side? Let's just divide by 4 plus c. I'm going to multiply the 4 plus c. Now, this time, since we're working with numbers and trying to find c, I say I'm thinking right here, I am actually going to multiply that c by the -1. And it's going to be negative, try this again, 4 plus c times -1, -4 minus c, still equals to the -3. And this is because I'm at the point of trying to find c. I don't know how you guys do this. Let's see. If I add 4 to the other side, -c equals -3 plus 4, which is 1. If -c equals 1, then c is -1. Now, put that together with your general solution, and I have y equals -3 over 4x cubed minus 1. And that is my particular solution. Okay. Notice there was one problem listed down below. Problem 2 needs to be changed to problem 17 from 74. However, I chose to skip 87, so I have 3 others written off to the side. 3, 4, and 9 are going to become 17, 18, 19 from 87. And that's because when these notes were originally created, 87 wasn't skipped, so. And this homework we will check Monday, but I am going to put on this last 9 weeks. Okay? Mainly because it's supposed to be due tomorrow.